Welcome to Physics World Online College, where we explain physics to the clearest understanding of the least students among us. Please remember to subscribe, remember to share with your friends and other students, and also remember to comment. We will respond to your comments from time to time. So in our class of today, we are continuing with the equations of uniformly accelerated motion. Today's class is centered on applying the equations we have already derived. Remember, let's refresh. We talked about the three equations of motion with a fourth one as a support. And the first one we said is V is equals to U plus AT. And the second one we say is S is equals to UT plus half AT squared. And the third one is V squared is equals to U squared plus 2AS. While the support one, which we refer to as the fourth, is S is equals to U half bracket U plus V close bracket T. These four equations we are going to apply in the class of today. We want to solve questions. But before then, there are statements of facts, important facts you need to know going forward for you to be able to apply these equations to solve simple problems. What are those points? Number one, whenever a body starts or begins from rest, anytime you read a question and it says the body, the car, the bus, the train starts from rest. Once you see from rest, begins or start from rest, it means you have been given something. What is that? The initial velocity of that body is 0. If you assume any other thing other than 0, you will be considered wrong. Number two, whenever a body comes to rest or is brought to rest, the point here is what? To rest. To rest. It comes to rest or is brought to rest. What does that mean? It means that the final velocity of that body or maximum velocity of that body or speed is equals to what? 0. V is 0 when the body comes to rest, while U is 0 when the body starts from rest. Number three, point to note, whenever a body moves with a uniform or constant velocity, this means that the acceleration of that body is what? Is 0. Here, the point is what? Uniform or constant velocity or speed. I need to throw a little light on that. Listen, that the body is moving with uniform or constant velocity or speed, it does not mean at every time the body is at rest. One thing you will understand as we continue in our classes here in physics, you see that a body that has acceleration at 0 means two things. One, it's either the body is not moving at all, so it's stationary. We consider the velocity to be 0, the acceleration is 0. Another case where the acceleration is 0 is where the body is moving, only that it is moving with a constant speed or velocity. It is moving with a uniform speed or velocity, meaning the initial velocity and the final velocity are equal. So the speed is steady. So once the velocity is constant, the body is not accelerating. So the acceleration is 0. A body only accelerates once there is increase in velocity. Once the velocity becomes steady or constant, it does not accelerate, even though it's in what? In motion. You have to take note of that particular point. So whenever a body moves with uniform or constant velocity or speed, the acceleration of that body is what? Is 0. Fourthly, once a body is retarding or decelerating with a certain value of retardation, in this point, while you read the question, you will see that the body is what? Retarding or decelerating. The velocity is decreasing, but they will give you a value that is positive. And you need to understand that a positive value of acceleration is acceleration itself. But once you see that the body is retarding or decelerating, even if the question gives you a positive value, you have to include a minus sign. That is what this point is saying, for you to proceed with the work, because retardation or deceleration is negative acceleration. So failure to put that minus sign means you are not going to get the correct solution for that problem. So these 4 points are important for us to proceed in our solving of problems with these equations. Have them in mind while we apply the question. So we have examples here to consider in today's class. So we have example 1 there. We'll take solution for example 1. So you follow as we take the solution. Example 1 says a car moves at 60 km per hour, accelerates uniformly at a car moves at 60 km per hour, accelerates uniformly at 5 meters per second square. Calculate its velocity after 2 minutes and then sketch the velocity time graph. So this is the way we solve our problems in physics for ease. First, pick the values that are given to you, the data that are given to you, declare them. So they say the car moves at 60 km. The first velocity that is mentioned is the initial velocity, in as much as it does not begin from rest. If it begins from rest, that initial velocity becomes 0. So a car moves at 60 km per hour means the initial velocity u is 60 km per hour. Now you cannot use kilometer per hour with meter per second square for the acceleration. That means you have to convert it to what? To meter per second. So here you will learn again, be reminded of how to convert from kilometer per hour to meter per second. Let's see that. You do what? 60 times 1 kilometer over 1 hour. And 1 kilometer in meter means 1,000 meters. So you multiply by 1,000. 1 hour in seconds means 60 times 60. That takes it to what? Second. So to convert from kilometer per hour to meter per second, simply multiply by 1,000 and divide by 60 times 60. That will convert it to meter per second. So if we do that, if you punch your calculator, you will see this value will give us 16.67 now meter per second. So we have converted the initial velocity to meter per second. Then we say the body accelerates uniformly at 5 meters per second square. It means acceleration A is 5 meters per second square. This is acceleration, not retardation. So we are not putting minus sign in this. So we are asked to what? Calculate its final velocity. Final velocity is letter what? V. We are looking for after 2 minutes. So we are giving time T as 2 minutes. We cannot use it in minutes. We convert it to what? Second. By multiplying by what? 60. That gives us 120 seconds. So for us to find the final velocity, we look at the parameters we are given. We'll check which of the equations connect them, and then look for the one we are asked to find. So from this, we have V, we have U, we have A and T. So the first equation of motion will be our friend. So we say from the first equation of motion, V is equals to U plus AT. That's the first equation of motion. Now we substitute. You state your formula. V is equals to, our U is what? 16.67 plus our A, acceleration, is 5 times our time is 120. This gives us 16.67 plus 5 times 120 is 600. If you add 16.67 to it, you have the final velocity is what? 616.67. You put your unit meter per second. So to solve physics problem, these steps are important. You declare the data that are given to you. You quote the correct equation. You substitute your values, and then you correct answer with what? The SI unit. If your unit you have put is wrong, mark will be deducted from you. Or if you fail to put any unit because you are not so sure, you will also lose that mark for not putting the right unit. So as you continue to learn, always learn the correct unit of each quantity. We are asked to sketch the velocity time graph. So it will be good to learn graph sketching as we solve problems in these equations of motion. So let me begin. So the velocity time graph, these are the steps to take when you are solving velocity time graph. For this example, first of all, you identify your axis. This is velocity with the unit meter per second. Velocity with meter per second. This is against time. Time in seconds. So we have identified our axis. Our origin is always 0,0. So we are told in this question, the body does not start from rest. So we are not starting from 0, but starts with initial velocity now converted to 16.67. So we are not drawing to scale. So you will use our discretion or common sense while sketching. It does not start from rest. So I'm not beginning from 0. I begin from somewhere up and then accelerate. So this is the initial velocity u, 16.67. This meter per second covers everything I write there. So it accelerates, goes up. With acceleration A, we put here the acceleration A, 5 meter per second square. And then for a time of 120 seconds, this is the time axis. You drop it down, you take a line, time 120 seconds. That's the time axis. Then this is the final velocity. When it starts here and accelerate, this is the final velocity or maximum velocity which we have looked for. We'll take it this way. That is V, which is now 616.67 meter per second. Obviously, you see there's something we could have been asked to find, which is the what? Total displacement of the body or total distance. And that one is covered by the area of this shape that we have described by this motion, X. We can be asked to look for it. So I will ask you to look for that total distance. It's not part of this class, but you can find it. Of course, equation 2 or equation 4 will be able to help you do that. So I say you can find the total distance using equation 4, which is S equals half U plus V times T. Let that be an assignment you will do after this class. So this is the solution for example 1. The solution for example 1. I will take example 2 now. I will take example 2. Example 2 says a train accelerates at the rate of 10 meter per second square from an initial velocity of 36 kilometers per hour. Find the distance covered during this period. Then also sketch the velocity time graph. So let's look at the solution to example 2. Solution 2 is solution example 1. The train accelerates. So we are given with the acceleration. Always start with what is given. Given A, acceleration as 10 meter per second square. From an initial velocity is u as 36 kilometer per hour. Once again, you cannot use it in kilometer per hour. You convert to meter per second. And how do we do that? I've said multiply by 1000 and divide by 60 times 60. If we do that, we are going to have that u will be what? 10 meter per second square. 10 meter per second for the initial velocity when converted. Then for a time of 30 seconds. So t is equals to what? 30 seconds. So we're asked to find the distance covered, S. Distance covered, X. We put it question mark. Once again, if you check these values that were given, you will check which of the equation has them and where we can make one the unknown. Once again, equation 2, the second equation of motion, will help us. So from second equation of motion, we have that x is equals to ut plus half at squared. That's the formula, so we can substitute our values. S is equals to our u is 10 times our t is 30 plus half our acceleration is 10 times our t is 30 square. And you know, please, 30 square is not 30 times 2, rather 30 times 30. Please try not to make that mistake. This gives us 300 plus half of 10 is 5, and 30 square is what? 900. If you multiply it by that, that gives you 300 plus 5 times 900 is what? 4,500. When you add it, you have S is what? 4,800 meter. So in kilometer, you can divide by 1,000. In kilometer, you get 4.8 kilometer. But meter is the preferred unit for solution. Now, we are asked to sketch the velocity time graph, which we can also do. So you learn how to sketch graph here. So let's see the velocity time graph for this question. The velocity time graph of example 2, we identify our axis, as I said. Identify your axis. This is velocity with the unit meter per second against time. This is the unit second. Our origin is 0, 0. Now, this body does not start from rest, so it's not starting from 0. It starts with initial velocity converted to 10. So you start anywhere other than 0 up and accelerate. So this is u equals to what? 10 meters per second. And then you will see that the final velocity is not known. So it's something you could have been asked to find. We are giving the acceleration a as 10 meters per second. You are seeing the place I'm putting there, each value. Then the time, 30 seconds, you take it down. That's the time axis, 30 seconds. And then the total distance is the graph, the shape of the graph. This is trapezium. The shape of the graph, S, is 4,800 meters. That's the position for the total distance or displacement. So, like I said, it means you could have been asked to find the final velocity v. So, to find the final velocity v, you use any of the equations that contains it. Third equation of motion can do it, and the first also can also do it. You could have used v is equals to u square plus 2as to find the final velocity. Let that one be also an assignment for you. So this is the velocity time graph for example number 2. We'll look at the example number 3. Look at example number 3 for solution. Let's look at it. We are told that a bus travels from rest. Good. So this question begins from rest. And I told you that whenever a body begins from rest, it means that the initial velocity of that body is 0. Unlike the first two we have solved, where it does not begin from rest, and we started somewhere other than 0. So this example 3 says a bus travels from rest. So when you read from rest, you have to take note of it with acceleration of 0.3 meters per second square. Find its velocity when it has moved a distance 50 meters, and also sketch the velocity time graph. So let's look at that. What are we given? We're given that the body starts from rest. The initial velocity is 0. Our reason is starts from rest. That's why the initial velocity is 0. Then acceleration A. is given as 0.3 meter per second square. And then we are given the distance s as 50 meter. So we are asked to find its velocity. So we are looking for the final velocity. We don't know. So that gives us which of the equations of motion covers u, a, s, and t. That will be the third equation of motion. So we say from the third equation of motion, we have that v square is equals to u square plus 2as. We substitute our values now. U is what? Is 0. So we have v square is equals to 0 square is also 0 plus 2 times 0.3 times 50. That gives us v square is equals to 0 plus this is 100 times it. That gives us what? 30. 0 plus 30, that gives us what? 30. So you take square root of what? Of 30. And square root of 30 will give us 5.48 meter per second. That is the final velocity of this body. Once again, for us to sketch the velocity time graph of this body, this body starts from rest. So what we are going to do, we take our axis, distinguish. This is velocity in meter per second. You always put the unit. This is time in second. The origin is 0, 0. Now this body started from rest. So it begins from where? From 0. So the initial velocity is 0. The final velocity we have looked for now, which is here, the maximum velocity v, is what? 5.48 meter per second. Here, this is u. U is 0 here. And then the time was not given. The total distance, which is area, if you check this shape, you see it's a triangle. So the total distance s is given as 50 meter. So one thing that is not given is what? T. So which means you could have been asked to find t. And to find t, you use any of the equations that have t. So that fourth equation of motion, we can use it. S equals to half u plus v times t. You make t the surrogate of formula. Or you use v is equals to u plus at. Make t the surrogate of formula, and you will find what? The time taken. So that one will be what? Assignment you will do as a follow-up. So these are the questions 1, 2, 3, applying the 3 equations of motion. We will look at the fourth one. We'll consider the fourth one.